This is a rather nasty looking question from a recent JEE main exam on domain of functions. Okay, so we're given this function here and we are asked to find what the domain is, and we're given four choices here, A, B, C or D, which we'll return to presently. Now basically, dealing with these domain of functions questions, they follow the same pattern. I'm not saying they're easy, but they do follow the same pattern in that you look at each function within the function and what the possible allowed values are for each of those functions, and then once you've got three sets of allowable, well, three in this case, but n, depending on how many functions there are, sets of how many allowable sets there are, then you take the intersection of those sets, and the intersection of the set will be the domain of the entire function. Okay, so here we basically have three sets. We have this one here, where we have log to the base half of x squared minus 5x add 5, and the answer to that then goes into log to the base 2, and we also have this greatest integer function, which we'll come back to in a minute, going into sine to the minus 1. Now just having a quick look at a couple of graphs, log to the base 2 looks like that's the point 1, and log never goes below 0, and it also never equals 0. Log to the base half looks like that. It's actually the mirror of log to the base 2 in the x-axis. Again, log to the base half never goes lower than 0, and sine to the minus 1 is basically the inverse of sine, and I'm bound to draw this appallingly, but let's have a quick look at it. Basically, sine to the minus 1 is going to be like that. Oh, that's not too terrible. Okay, well, I'm quite pleased with that. Where basically the value has to be between 1 and minus 1, but it can be 1 and it can be minus 1, whereas the log function cannot be 0. So armed with all of that, let's go and let's take one at a time. So first of all, when we look at this here, log to the base half of x squared minus 5x plus 5, well, we know that cannot be less than 0. So that's the first thing. So x squared minus 5x add 5 must be greater than, not greater than or equal to, must be greater than 0. Okay, so that's A. Let's have a look at B. Well, B, whatever comes out of this thing here, must also be greater than 0 because it goes into another log function. So we also know that B, log to the base half of x squared minus 5x add 5 is greater than 0. And C, looking at C, we look at the sine to the minus 1, we know that this thing here must be between 1 and minus 1. So we know that the greater integer function 2x squared minus 3 must be greater than or equal to minus 1 and less than or equal to 1. Okay, so let's deal with each one of these in turn. A, x squared minus 5x add 5 has got to be greater than 0. Well, we can solve this. Let's just do the x squared minus 5x add 5 equals 0. Using the quadratic formula, we would get x equals minus b plus or minus the square root of b squared minus 4ac over 2, which is 5 plus or minus root 5 over 2. And we know, because the coefficient of x squared is positive, we know that it looks like that. And so therefore, we know that this here is greater than 0 when x is greater than greater than 5 plus root 5 over 2, or less than 5 minus root 5 over 2. So writing that in set notation, we would have that x, for A, x would have to be contained in minus infinity to 5 minus root 5 over 2, union 5 plus root 5 over 2, infinity. So that is basically the set that x must belong to in order that A is satisfied. And remember, this is a curved bracket, not a square bracket, because the value cannot be equal to 0. Okay, now let's have a look at B. All right, well, basically, log to the base half of this must be greater than 0. Well, looking at log to the base half, log to the base half was this one. That means that it must be less than 1 in order for that to be satisfied. So B, we have that x squared minus 5x add 5 must be less than 1 from here in order that that function has a value. So looking at this one, that gives us x squared minus 5x add 4 has got to be less than 0, or we can factorise that as x minus 4, x minus 1 has got to be less than 0. And again, we can draw that one if we want to. Basically, it will go through the points 1 and 4. And so therefore, this will be less than 0 when x is between 1 and 4. So B, x must be contained in the set 1, 4. And again, we're using the curved brackets because this cannot be equal to 1. Now let's have a look at C. C, let's keep it on the screen if we can. C is this one here. So basically the greater integer function rounds it down to the nearest integer. So basically we need this to be between 1 and minus 1. Well, that actually means that 2x squared minus 3 can be actually all the way up to, but not including 2, because it would then get rounded down to 1. Remember, if we had equals to 2, it would not get rounded down to 1. So we cannot have it equals to 2. It must be less than 2. And also it must be greater than or equal to minus 1. Okay. Now looking at this, that means therefore that 2 must be less than or equal to 2x squared, which must be less than 5, i.e. 1 must be less than or equal to x squared, which must be less than 5 over 2. And from this, we therefore have that x must be contained in minus root 5 over 2 minus 1. And this is a square bracket this time because it can equal minus 1, union square bracket 1 root 5 over 2. And that is a curved bracket. My apologies, that's important that I get that right. That's a curved bracket because it cannot be equal to that. That's better. Okay, you've got to be careful with these. Okay, so now let's have a look at these. All we need to do now is look at the intersection of the 3. Let's just get a little bit of clear space. So we have basically that x must be contained in, this is from the first one, minus infinity 5 minus root 5 over 2 union 5 plus root 5 over 2 infinity. That's from the first one. And the second one we have x must be contained in 1, 4. And the third one we have x must be contained in minus root 5 over 2 minus 1 square bracket union 1 root 5 over 2 curly bracket. Now you could probably do this by inspection, but anyway, as this is the first time, let's do it on a number line here. So what we need, let's have a look at a number line here. We've got a number line here, and we've got number 0, minus 1, minus 2, minus 3, minus 4, and we've got 1, 2, 3, 4. Let's have a look at this first one here. Let's call that A, and I'll tell you what, let's draw that in a different colour. So let's let this one be A, which is this one. So how does that look on a number line? Well, basically it goes to 5 minus root 5 over 2 is approximately 1.38. So that means that A goes from minus infinity to around 5 minus root 5 over 2, but not including it. So basically that is allowed to be there, and then 5 plus root 5 over 2 is about 3.6 across to there. They are all the values that A can take on a number line. And let's have a look at B. Let's try a different colour here. B, x is between 1 and 4. So let's draw that. So it will be here. This is B. There's 1 and 4. Again, because it's an open circle, because these are curved lines. And let's have a look at C. Let's finally draw a different colour again. Let's have a look at green. So C, x has got to be contained in minus root 5 over 2. Well, basically, that would be minus 1 here. Now, because it is a square bracket, we have a closed circle there. It's allowed to be minus 1. So it would be that union, oh sorry, to minus root 5 over 2, my apologies, to minus root 5 over 2, which is around minus 1.58, so it would only be to around there. My apologies. So it would be to around there. And that would be like that. Union, this one here, which is 1 to root 5 over 2. So again, we would have the closed here, and root 5 over 2 is around root 5 over 2 is about 1.58, so that goes to around here. Okay, so basically the final answer to the domain of the function is where this thing, where all of these three intersect. Well, clearly all of these three intersect here, which is at the number 1, but not including the number 1, to the number here, which was 5 minus root 5 over 2, but not including root 5 over root 5 minus 2. They are the only bits which are covered in all three of the sets that we've looked at, and so therefore the answer is that the domain of the function in the question is 1, which is that bit, to 5 minus root 5 over 2, which is that bit there, which was answer C, right at the beginning here. Okay, well I hope you found that useful. You do have to be careful on these things, and you probably don't need to take as many steps as I've taken here. I mean, this is an instructional video, so I've probably gone into it in more depth than you need to. I hope you found it useful. If you have, please like the video and subscribe to the Gresty Academy YouTube channel. Thank you.